Okay, so for your warm-up, you're going to Desmos, right? Graphing calculator, and then you're putting in these 2 points, 1, 2, and 2, 5. And then you're going to try to make a parabola that goes through those points. This is not something I've taught you how to do. It's something where you're going to kind of explore, be like, what do I know about parabolas? How do I change them? How do I get them to move around, maybe change, and go through these points, right? So if you went to Desmos, you'd put the 2 points in, parentheses 1, comma 2, parentheses 2, 5, and then you would start graphing. I would imagine you start with the parent function, you go from there, right? How do I change a parent function? How do I make it go where I want it to go? Okay? So you're going to see if you can do that. See if you can get through those points. Okay? Question?
Can we use one of them as our vertex?
Sure. All right, so give it a shot. What are some things you can change about a parabola to maybe make this happen? Stretch. Reflection. What's that? Anything else? Yep, translation. So moving right, left, up, or down. Okay? All right. So we want our parabola to go through these 2 points. So is anybody able to figure out a way for that to happen? Yeah. What'd you get? What'd you do?
Y equals negative, and then in parentheses.
So you flipped it down. You had a negative, and then parentheses.
X minus 3.
X minus 3.
And squared.
Squared. Okay.
Plus 6.
Plus 6. So what did you end up trying to do there?
Because I saw that between the 2 points, it just went over 1 and down 3.
Okay.
Which reminded me of like when the base function, because it's over 2, down 4, so I could just make a vertex and have it go through the 2 points.
Okay, cool. Anybody get a different function? Yeah.
I did y equals 3, parentheses, x minus 1 squared, plus 2.
Nice. Cool.
I did.
You got one?
Yeah.
What'd you get?
Y equals x squared plus 1.
Oh, that's easy. X squared plus 1. Make that one orange. Okay. Anybody else get one?
I got. What did you do up there?
I don't know. You tell me.
No. Y equals negative 3 parentheses x minus 2 squared plus 5.
Plus what?
5.
Look at that. Awesome. Anybody else? Or maybe you had one that's already up there? Right? Okay. So we flipped it around, we moved it. Some people said, I'm going to make one of those my vertex. Some people said, okay, I'm going to start where I know the parabola pattern will go through it. Right? Some people just moved it up 1 and it worked. Right? So, okay. What if I wanted everybody to get the same equation? Have I given you enough information?
No.
No. What else could I say to make sure everybody got the same equation?
The line of symmetry.
Okay. Be more specific. Like, what about what part of the line of symmetry?
Vertex.
The vertex. So if I told you one of those 2 points had to be the vertex, right? You would probably be able to all find the same equation, maybe 2 equations, right? Because it could be like, what if I told you that one was the vertex? Well, then we'd all have the same equation. If I said one of the 2 was the vertex, it could be that one or that one, right? Now, is there any other way I can make sure you all got the same equation? Besides to tell you one of them is the vertex. What more information could I add? What do you think? What if I gave you a third point, right? If I gave you a third point, then we're all going to get the same equation, right? So those are our two scenarios today in our lesson, right? We're going to be given 2 points, and I tell you one's the vertex, or you're going to be given 3 points, and 2 of them turn out to be x-intercepts, okay? Just to make this a little simpler for us. But that's going to be the situation so that we all get the same equation, right? With that much information, you will be able to write equations, right? So that'll be the trick today. Can you write an equation given a couple points or given 3 points, and you will need to know, oh, is this a vertex situation? Is this an intercept situation? So that's where we're going, okay? So I just thought it would be interesting to have you kind of have to play around to do it, right? Because I'm going to give you a way to solve for it, okay? So I always like to give you the long way and then show you the short way so you can truly appreciate it, right? All right, so on your notes, so today what we're going to do is we're going to write equations given some points, okay? Before we do, we got to know, we're going to be told things about the graph, right? We're going to be said, okay, this is what's true about the graph, write your equation. We need to be solid on what is in each equation. So in these boxes, we're going to write what these give you on the graph. Okay? So, in vertex form, what does my A give me? What's your A give you on stretch, end, stretch, shrink, end, and your reflection? Is that true for all forms?
Yes.
Yep, that's all the way across, right? Stretch and reflection for all of these. A gives you that. What is my HK? That's my vertex. Right? In here, well, my A is my stretch and my reflection. What is my P and Q? They're my x-intercepts. And then finally, in standard form, yeah, my A is my stretch and reflection. There's one thing that's given there that you can see on the graph. What is it? The C is my what? My C is my y-intercept. Okay. We just got to be solid on what we're given so we know what form to use when we're given things. Okay? So the first thing we're going to do is write an equation using vertex form. So in any of these equations, they're going to give you the vertex, which is great. But think about vertex form. If I just give you the vertex, do you have enough to write the form? What's missing? A. So in all these situations, we don't know our A. Okay? We don't know A. So we got to find it. Okay? Now, when you're going to use vertex form when you're given 2 points and 1 is a vertex. So if I give you 2 points and I tell you one's a vertex, you're using vertex form to find your A. Okay? All right, so here are your steps for writing equations using vertex form, and then we'll do some examples. Okay? First step is plug in your HK into y equals a times x minus h squared plus k. Right? You plug in the HK that you're given into that. Okay? Now, remember when we did y equals mx plus b, and I said, okay, what if you don't know your b, and I'm just giving you some points? Right? You find your m, but how did you find your b? Anybody remember? I gave you points. What are points? What's in a point?
Slope.
X and y. And do you remember what you did with those?
You would find them through the b minus b divided by 2a.
No, I'm talking about when we did linear equations, right? You had y equals mx plus b. I gave you points. You had your m. You found your m. you would plug in the x and y to solve for your b.
Right.
That's what we're going to do here. We're going to plug in x and y and then solve for our a. So next, you plug in your point, your x, y, into x and y in the equation. And after you do that, you'll have nothing left but a, so you solve for a. And then after you find a, you can plug in a, h, and k into the equation. Okay? So that's what we're doing. Those are our steps. So your problem will look something like this. It won't tell you what form to use, but there are clues in the problem. For instance, it says, a parabola has a vertex at 4, 5 and passes through the point 6, 13. Write an equation. That's all it tells you. That's all it gives you. But it's enough. Now, what is the clue in there on what form we're going to use? It gives you your vertex. Let's use vertex form, right? So if it gives you your vertex, there's 2 points, that's enough. We're going into vertex form, all right? Everybody still ready? Okay. So vertex form, we know that's y equals a times x minus h squared plus k, right? So our h and our k are given. What are they? 4, 5. What else is given here? A point of x, y. So that's 6, 13. Okay? So those are the things that we're going to use to help us. The first step is to plug in our h and our k. So y equals a times x minus 4 squared plus 5. Okay? So that is our h and our k going into the equation. Okay, our next step is to plug in our x and our y. So what goes in for y?
13.
So 13 equals a times, what's our x? 6 minus 4 squared plus 5. Okay, now I just need to solve for a. Okay, so what would I do first here? 6 minus 4 inside parentheses, and that, so it becomes 13 equals a times 2 squared plus 5. What is 2 squared?
4.
4. So we're going to have a times 4, but do we usually write a4 or? No, like when we have a number times a letter, what do we usually write first?
Number.
The number. So it's really 4a, right? This is a times 2 squared, this becomes 4a. So this is 13 equals 4a plus 5, and now we just solve for a, right? Minus 5, go over here, and I get 8 equals 4a, divide by 4, and 2 equals a. Okay? So I've found my a value. Okay? Now, I have my a. I already had my h and my k. I just write my equation now. So y equals 2 times x minus 4 squared plus 5. And we know that this parabola would have a vertex of 4, 5 and would pass through the point 6, 13. Okay? Now I want you to try the next one on your own. Okay? So use the steps that we just used and try to replicate them with the next problem. Find your HK, find your XY, plug them in, solve for A. All right, we ready? Okay, so parabola has a vertex of 2, 3 and passes through the point 3, 8. So it gives us a vertex, gives us 2 points. We know we're going to use vertex form. So my vertex form y equals a times x minus h squared plus k. What are my h and k in this case? 2, 3. Yeah. And then what are my x and y? 3 and 8. Now, I put it as separate steps. If you want to plug them all in it right away, you can. Okay, I'm going to do them in separate steps. So first we'll plug in our h and k. So y equals a times x minus 2 squared plus 3, right? Then we'll plug in our x and y. So that was that step. This is the next step. So I get not y equals, what's my y? 8. 8 equals a times 3 minus 2 squared plus 3. Okay, so 8 equals, now what is 3 minus 2? 1. What is 1 squared?
1.
What is 1 times a? A. We see that? That's where we want to see it out. Okay, 3 minus 2 is 1, so I get 1 squared plus 3, right? 1 squared is 1, so I get 1a. So 8 equals a plus 3, minus 3 minus 3, a equals 5, right? So my a is 5, and my h and k are 2 and 3. I have everything I need, right? Questions? Okay, so y equals 5 times x minus 3 squared, what, not 3? 2 squared plus 3. And I have my vertex form. I know the vertex, and I know it goes to the point because I proved it. Okay? So that's one scenario. Question?
You get x minus 2 squared from 1 squared.
So 1 squared, was just when I was solving for a. And then once I got my a, now I have to write the full equation. So then I put a here, I put h here, I put k here. Yeah. All right, so that's the scenario where you have 2 points and one's a vertex. The next scenario, you'll have 3 points and 2 of them are x-intercepts. Okay? So now we're going to have 3 points and 2 are x-intercepts. This is scenario 2. And you're not always going to be told, hey, this is the time you use intercept form. This is the time you use vertex form. You got to be able to recognize the difference, okay? So 3 points and 2 are x-intercepts. Of course, that's our intercept form. Very similar steps. Plug in your P and Q into that equation, right? Plug those in. Then plug in your point, your xy, into the same equation. After you do all that, you only have a left, and you can solve for a. So step 3, solve for a. Right? And then after you get all of those, you plug a, P, and Q into the same equation. Okay? So what does that look like? We'll go through examples. Okay? Your first example says a parabola has x-intercepts of -1, 0, and 10, 0, and a point at 0, 10. Write the equation. Okay? So, again, we start with y equals a times x minus p, x minus q. And then we think about, what do we know? Well, our p and our q are what? We know our x-intercepts. So what are our x-intercepts? -1 and 10. Right? Those our p and our q are our x-intercepts. You don't change any sign at that point. Okay, what else do we know? We have an xy of what? 0 and 10. Okay, so now we start plugging things in. First, we plug in these. I get y equals a times, okay, if I have x minus 1, it becomes plus 1. And then I have x minus 10. Okay, with me so far? Okay, now I'm going to plug in my x and y. So I get 10, you're ahead of me, equals a times 0 plus 1, 0 minus 10, right? Which gives me 10 equals a times 1 times negative 10. So on that side of the equation, what do I have?
10 equals negative 10a.
Yeah, 1 times negative 10 is negative 10. Negative 10 times a, it's negative 10a. So 10 equals negative 10a. And then I solve for a. Divide by negative 10, divide by negative 10. I get a equals negative 1. So now I found that missing a. I also already had my p and q. So I have everything I need to write my equation now, right? It will be y equals, what's my a? What did I find? Negative 1, and then parentheses, x minus 1 plus 1, and then x minus 10. Okay? Now, do we need that 1 there? No. So, I'm a little bit of a nitpicky guy myself. If you left it, that'd be fine, but you really don't need it. Okay? So it's negative x plus 1, x minus 10. Question? Oh, yeah, sure. Okay, so try that last problem. While you're doing that, I'll hand out your homework, and then we'll go over it and we'll be done. Okay? Okay, so here we have y equals a times x minus p and x minus q. So I know my p and my q, and I know an xy from the situation. It said x-intercepts of negative 3, 0, negative 7, 0, and a point at negative 1, 6. So what's my p and q? Negative 3, negative 7. What's my xy? Negative 1 and 6. Okay, now I plug them in. So y equals a times x minus 3 is plus 3, and minus 7 is plus 7. Right? Now I plug in my x and y. What's my y? 6 equals a times negative 1 plus 3, negative 1 plus 7. Okay, so I get 6 equals a times 2 times 6, right? What's 2 times 6? 12. So I get 6 equals 12a, and then I divide by 12 on both sides. What do I get for a then? 1/2. Is that possible to have an a that's 1/2? It's a shrink, isn't it? Right? We can have those, right? So I got my a, I got my p and q. I just bring it all together. Y equals 1/2. X minus 3 is plus 3. Minus 7 is plus 7. And I have my equation. Good job.
Automatically, instead of letting me write it, I can automatically put the P and Q.
Just be careful. Make sure you always think about it, because there's so many times where students flip them at the wrong time. Don't leave. You don't want to get tardy. So, yeah, make sure you think it through. Let's go to the homework, though. So, see if we have any questions on the homework. All right. So, on the homework, it was all about converting. So, I want everyone to have their converting graphic organizer in front of them, right? So that you can answer questions about these steps, right? Because you should be able to, with every one of these questions, go, okay, I'm starting with this, I'm trying to get to this. Let me look at my graphic organizer, see which steps I got to take, right? Everyone has that in their power now. All right? So on the front, it was a bunch of different situations. Standard to vertex, vertex to standard, standard to intercept, vertex to, well, intercept to vertex. So that was a hard one, right? So which ones do we want to see on the front? Let me know. What do you want to see? What is that? To be? To be or not to be? Anything else?
A.
Which one?
Second, not 1 or 2 there.
3A?
Oh yeah, there is 3 on
Okay. Any others that we would like to see? Yeah. 3A, okay. Anybody want to see one from 1? No? Okay. All right, so let's start with 2B. Okay, so 2B, it says convert the following to intercept form. So that's where we're going. We need to know where we're starting. What form are we starting in? Vertex. So I'm going from vertex to intercept. Somebody tell me what number that is on our graphic organizer. Vertex to intercept. 4. And what are the instructions? Okay. So we can't go right from vertex to intercept. We have to go vertex to standard. And then we go from standard to intercept. Okay, so we're going to go vertex to standard first, right? Well, how do I go vertex to standard? What number is that? What number is vertex to standard? 3, right? So what does 3 tell us to do? Can you repeat that? How do we go from vertex to standard? Okay, let's do that before we go to the second part. So I'm expanding or pulling apart. What am I pulling apart? The parentheses squared. So this becomes 4 times x plus 1 times x plus 1 minus 36. Okay. What's the next step say, Bryce?
Foil a box.
Okay, so what do you think we're foiling or boxing? Yeah. So I'll go x plus 1 times x plus 1, right? If I FOIL that, first, outer, inner, last, right? I get x squared, that's plus 1x, so that's plus 2x, right? And then 1 times 1 is 1, so plus 1. Okay, so if I FOIL x plus 1 times x plus 1, I get that. Question?
When you FOIL, like, can you go from, like, 1x, so I think that's inner?
Yeah.
Would that just be 1x?
Yeah, 1 times x is just 1x, right? And then this was 1x, and the outer was 1x. So you add them together, you get 2x, yeah. Yep, good question. All right, so then that means that this part becomes that. So I get y equals 4 times x squared plus 2x plus 1 minus 36. And now what's the next step?
We let 36 inside?
Well, I can't because there's a number on the outside. So I got to distribute the 4, right? So if I distribute the 4, I get y equals 4x squared plus 8x plus 4 minus 36. And now I can do that math with the 36 because I have 4 minus 36. So I get y equals 4x squared plus 8x minus 32. Okay. Now, that's great, but they weren't asking for standard. They were asking for what? Intercept. So we're halfway there. We need to convert to intercept. So how do I convert from intercept? Because I'm in standard now. Standard to intercept. What are the steps? Yep. Factor out your GCF and then magic X. So what's my GCF? It's always my what? my a, right? So I'm going to factor out the 4. So this becomes y equals 4, and then big parentheses. And when I factor out, what do I do with everything? Divide them by 4, right? So divide by 4, divide by 4, divide by 4. I get x squared plus 2x minus 8. Okay, let's take that over here. X squared plus, well, hold on, y equals 4 times x squared plus 2x minus 8. And then what's the next step after we factor the GCF? Use magic x, yeah. So I got minus 8 on the top and 2 on the bottom. If I'm multiplying to get a negative, it's a negative and a positive. What two numbers multiply to give me negative 8, and then they come together to give me 2? 4 minus 2. Right, so negative 2 and 4. So I just plug those in as they are. Y equals 4 times x minus 2 times x plus 4. And I am now in intercept form. So I completed the journey of a vertex all the way to intercept. Okay? All right.
The problem is when I took the 4 out, I didn't divide them. That's why this is.
Ah, okay. Yeah. So when you take the 4 out, you got to divide everything inside by 4. Yep. Okay. What was the other one we wanted to look at? 3A. All right, so 3A. It says convert to vertex form and use both methods. Okay, so this is intercept form, and we've got to get to vertex, right? So we talked about in the two options where you find the pieces and you plug them into vertex. So that's the first thing we're going to do. The other option is to convert to standard and then convert to vertex, right? So y'all chose some longer problems here, which is fine because those are the harder ones. I get it. All right, so first we're going to try to just plug in the pieces for a x minus h squared plus k, right? So we need our a, our h, and our k. Okay, our a is always given in the original. What is it? 3, right? It's always in that first one. And then our h and our k are our vertex, right? So we need to find our vertex. So in order to do that, we need to do this thing, right? So we need to know our p and our q from the equation. What's my p and what's my q?
5 and 7.
Exactly. This is when we flip out the sign. My p and my q are my x-intercepts. Anytime I'm asking for x-intercepts, I flip the sign from the equation. So I do x equals 5 plus 7 divided by 2. That's 12 divided by 2. That's 6. So my h is 6. That's the x of the vertex. Plug it back in to find our y. So y equals 3 times 6 minus 5 times 6 minus 7. That's 3 times 1 times negative 1. 3 times 1 is 3, times negative 1 is negative 3. So my k is negative 3. Now I have every piece I need to plug in here. So y equals 3 times x minus 6 squared minus 3. So I've converted it to vertex form using p plus q divided by 2 and finding the pieces. Okay? That's always one option, right? The other option is to convert it to standard form and then complete the square. Okay? All right, so that's what we're going to do now. So I got y equals 3 times x minus 5 times x minus 7. Now I have intercept form and I want to convert it to standard form. What are the rules? What are the steps? Intercept to standard. We all have them.
Intercept to standard.
Box or foil?
Foil or box first, and then distribute. So it'll be 3 times whatever that ends up being when I foil or box it, right? If I do that, it becomes x squared minus 12x plus 35. Right? That's if I foiled or boxed x minus 5, x minus 7. Now I distribute, and I get y equals 3x squared minus 36x plus 105. Okay, that got me to standard. Now I need to go to, what were we trying to get to? Vertex. So I have to complete the square. So I kick out the c, y equals 3x squared minus 36x, leave a space, plus 105. Now before I can complete the square, I need to move out my a, so I need to pull out the 3, right? So I'm going to pull out the 3, y equals 3, and then I divide everything in here by 3. 3x squared divided by 3 is x squared, and then negative 36 divided by 3 is minus 12x. So then I'm ready to complete the square. You complete the square by doing b divided by 2 squared. What's my b in there? Negative 12 divided by 2 is negative 6. Negative 6 squared. Negative 6 squared is 36. So I'm going to add 36 here. Okay? Now, what did I actually add to the equation here in terms of damage?
Negative 108.
No,
To get 36?
So you do b divided by 2.
Yeah.
So that's negative 6 divided by 2. So 6 squared.
36 times.
So 3 times 36 is what I added here, which is 108. So I need to subtract 108. Yep. So I end up with y equals 3. This becomes the perfect square. And then over here I have minus 3. And then in the perfect square, I always put x, and then b divided by 2, which is negative 12 divided by 2, which is negative 6. And that gets me to the same vertex form. Okay? Okay. All right. I think we got to get to the lesson. So are we okay on the homework?